Hi, today we have 1642. Let me share screen. 1642 first building you can reach. You're given integer array of heights represented the heights of the building, some bricks and some ladders. You start using a journey from building 0 and move to the next building, possibly using bricks or ladder. While moving from building I to building I plus 1, if the current building is height greater or equals the next building's height, you don't need ladder or bricks. Okay. If current building height is less, building height, you can either use the ladder or use the bricks. Return the furthest building index you can reach if you use the given ladder and bricks optimally. Okay, so basically, obviously, we can put difference between buildings I and I plus 1 into heap. Then we will use ladder on largest. Then we use bricks on other. And we have to return all equals 4. So if the fourth building we can reach, right? We have to return the furthest building you can reach if you use a given ladder optimally. Okay, but how we figure out how long we gonna go there? So what if we have a function that will so my question is how we calculate the distance. So for example, we have a function can reach. It does look like optimal function parameter, right? And then if So for in range can reach building SAD. For in range B, we're gonna do if heights is more than e plus 1. We do nothing, we just move forward. Less than heights. Then here we have to decide um, bricks or ladders. How are we gonna decide that? We need to know that the distance is so is then in top of the heap. Use ladder. Otherwise, use bricks. It's like here they used bricks on a higher distance, but ladder on the short distance. But obviously, if you use ladder first, then you can use bricks here and maybe bricks here, right, to jump over. Why don't you use ladder first? Let's call it like um, heights tips. So we have index and value, right? Example, maybe. But the thing is, it doesn't work because, like, for example, if we calculate heights, right? If we calculate heights on this array, what we're gonna have? 2, 4, nothing. 7, 6, 2, 7. Then we have 5, 7, 6, nothing. 6, 9. We have 3. 9, 14. We have 5. 14, 12. We have nothing. So at result, 0, 1, 2, 3, 4, 5, 6. So if we always use ladder first, so heap, so we're gonna have 2, 5. Then we're gonna have 5, 5. Okay, let's call it, I'm writing it backwards. 5, 2, 5, 5, and then 4, index 4, 3, 4. So does this mean that we can use ladder and then bricks and max index will be how which one we reach, so we can reach 5, right? So in this case, we have 5 bricks and 1 ladder. So 5 bricks, 1 ladder. So we're gonna go. We use ladder on 5 too. we use on 5.5? We cannot use on 5.5, right? Because this is the next what we can use. We need to use on 3.4 first. I kind of have to do them to be sorted by that thing, but by volume, right? By heights and also by index, because I cannot use just 5 bricks on this and say I can reach 5, which is not true. I can use 3 bricks and reach 4. So what if I create this and then I enumerate heights? And then I have, for example, here I may have uh, 0, 1. So I find for 0, 1. Yeah. Okay, let's go back to brute force then. In brute force, how could I do that? Start for E in land heights. Let's call it H. We call land of heights. H if letters is so yeah, if the same. Yeah. So if heights, then if letters less more than 0, we decrease letters. Bricks more than 0, if then if there are enough bricks for heights, we decrease bricks, right? Else return height. And that's it. That will be our solution. But this is not correct approach, or not optimal approach, because sometimes it will be because of this decision making. So we have to have not like just we don't have to assume that we can use ladders anytime. We have to make like if the ladder is somehow in the highest difference, highest weight or something, or like we have to calculate like difference and in weights. How to do it? Okay, let's try this for fun. Maybe if I have it failed on some cases, I will have idea how to do it. So, um, yes, I have no idea how to make decision where to use ladders, where to use bricks, when to use ladders, and when to use bricks. If can I use bricks anytime? And then if I'm out of bricks, I can use ladder. Yep. then at the end we return H. Oh, okay, here. Uh, yeah, see, so it's working for this case. For this case, if I use ladder first, for this case, and for this case, but for this case it didn't work. I have 10 bricks and I use 2 ladders. What if I change? Yeah, so I have to figure out when to use bricks and when to use ladders. If we have a measurement first, can I decide um, but in which, how I can use it? Like if I say here, if this is the highest, right? If this is the highest, I would use ladder. If this is highest, I would use ladder. But what if this is second high, second highest? Yes, obviously. Yes. So how to identify until when I have to use a ladder? Yeah, my time is over, and I still don't have any idea how to make this decision. Which should I? How should I use? How should I weight my decision between using bricks and using ladders? And sorry, that's it for today. Thank you.